This lesson addresses the target number 7.4 in Unit 7 in regards to the mole or molar ratio. Target 7.4 states that you should be able to use a molar ratio from a balanced chemical equation to convert from moles of A to moles of substance B, and vice versa. Here is our flow chart. If we start with mass of substance A, we can then find moles of A, and from that we can multiply by the mole ratio to discover the moles of B, and from then we can discover and calculate mass of B. Today's lesson involves just the part in the blue dotted circle. Converting the moles of one substance, we'll call that A, to the moles of another substance, we'll call that B. And by doing that, in order to do that and accomplish that, you will simply be multiplying by a mole ratio. So, given an equation N2 plus 3H2 yields 2NH3. Our task is to calculate the moles of H2 needed to react with 4 moles of N2. So we're talking about 2 reactants, and we have 4.00 moles of N2 to start. So that's going to be our substance A. Anything that's given is going to be our substance A. Anything we're solving for is going to be our substance B. So when we convert moles of A to moles of B, we know A and we have to solve for B. In order to do that, we have to identify some mole ratios from the balanced equation here. So let's do that. Let's identify 6 mole ratios from this balanced equation. In math, you may call ratios fractions. In chemistry class, we call them mole ratios. But nonetheless, there will be a numerator and a denominator. The numerator will contain the substance that we are solving for. And the denominator will contain the substance that we are given, and we will cancel to solve for B. All right, for example, looking at this balanced equation, N2 plus 3H2 yields 2NH3, you can see the coefficients in front of each of the reactants and products, and those are going to become our mole ratios. So for 1 mole of N2, 2 moles of NH3 will be produced. And for every 2 moles of NH3 that's produced, we will react 1 N2. So we can also write it as 2 moles of NH3 will result from reacting 1 mole of N2 in this equation. Each of these is a mole ratio, and depending upon what you're solving for will determine which ratio you choose. Continuing on, for every 3 H2s reacted, we're going to need 1 N2. And for every 1 N2 we react, we're going to need 3 H2s for this reaction to happen. Okay, so now we have 1, 2, 3, 4 ratios. Let's come up with 2 more. Now we can compare the moles of H2 with the moles of NH3. So for every 3 moles of H2, we will produce 2 moles of NH2. Now you may have noticed that I stopped writing the word mole. I'm really worried or focused on the ratio itself, but truly what this means is 3 moles of H2 to 1 mole of N2. Just like this coefficient means 3 moles of H2 in the reactants, but we don't necessarily have to write it to mean it. So So you can choose to write out the moles, or you can just write the ratio with the molecule or the reactant or product next to it. So if we want to produce 2 moles of NH3, we're going to have to react 3 moles of H2. So now we have 1, 2, 3, 4, 5, 6 mole ratios. Now let's use those to calculate the moles of H2 needed to react with 4 moles of N2. So you always start with what you know, and with what you know is 4.00 moles of N2. We always put that over 1, and we multiply it by, in this case, the mole ratio. One of these mole ratios corresponds to just calculating how many moles of H2 are reacted if we begin with 4 moles of N2. And this is determined by multiplying by the mole ratio. So we want the N2 to cancel. So the moles of N2 will go on the bottom, and it will make a ratio with the moles of H2. So this is the H2, that's substance B, which we are solving for. These moles will cancel. So let's find a ratio with H2 at the top and N2 at the bottom. It happens to be a 3:1 molar ratio. Our moles of N2 cancel. We'll be solving for an answer with moles of H2. And to do that, you will just multiply 4 times 3, which is 12. And then you will keep the significant digits according to the measured value given in substance A, which is 3. So this is how you could approach this calculation. Control divide, 4.00 times 3 over 1 times 1, and the answer is 12. We need 3 sig figs, so we might write 12.0 moles of H2 are required to react with 4 moles of N2 to get the product. This is one example of mole ratio. We'll use the same equation and we'll do one more example for mole ratios. Okay, so the equation we're going to use is still N2 as a gas plus 3H2 as a gas yields 2NH3 as a gas. And all of the mole ratios are still the same, so we've got 1 mole of N2, 2 moles of NH3, and then 2 moles of NH3 to 1 mole of N2. And we've got 3 moles of H2 to 1 mole of N2, and 1 mole of N2 to 3 moles of H2, and then 3 moles of H2 to 2 moles of NH3. And the last mole ratio we could possibly use is 2 moles of NH3 to 3 moles of H2. Okay. So the question is going to be, question number 2 will be calculate the moles of N2 required to produce 1.00 moles of NH3. So in the first example, we were dealing with two reactants. In this example, you'll see it's the same mathematical method, but we will be using our starting point as one of the reactants to figure out, our starting point as the product to figure out how much of the reactant we need to make this many moles of product. So it's the same mole ratio idea. We will just pick a different mole ratio. All right, so we write what we know, which is 1.00 moles of NH3 all over 1 times moles of NH3 in the denominator so that they can cancel. And we want to solve for moles of N2. Okay, so we have to pick one of these mole ratios at the top with N2 as the numerator and NH3 as the denominator. And that's the very first mole ratio. So we would have 1 mole of N2 being reacted in order to produce 2 moles of NH3. And we would control divide 1.00 times 1 over 1 times 2. And your answer is 0.5. We need 3 sig figs set by our measured value. 0.500 moles of N2. So if you missed it, here's your lesson in mole ratios. This will help you complete page 706 in your workbook. Both numbers 10 and numbers 11. Good luck.